Hello, this is Dr. Tom with a presentation on NCEES problem number 14. This particular problem is on the first law for open systems. So let's get started. Okay, the NCEES solution suggests that the enthalpy of the mixture is simply an average of the enthalpies of the incoming water and steam. Not showing how this equation was determined has been very confusing. People asking why is it an average? And a figure like the following would have been helpful, where you see water and steam coming into the mixing chamber and a mixture going out. Okay, so with mixing chambers, apply conservation of mass. The sum of the m dots in equal the sum of the m dots out. So therefore, you'd have m dot water plus m dot steam equals the m dot mixture, where you're given that the m dot water and the m dot steam are equal to 100 pound mass per minute. And this is where it comes out to where it looks like an average. Okay, so therefore the mixture is 200 pound mass per minute. Okay, now apply the conservation of energy, meaning the first law for open systems with multiple inlets or outlets. And we're not going to have any heat transfer or work done by the fluids. They're going to neglect changes in kinetic and potential energy. So what you have is the sum of the m dot h's going in equal to the sum of the m dot h's coming out. Okay, so what that means is m dot water times h water plus m dot steam times h steam, that's the 2 coming in, equals the 1 going out, the mixture m dot times h mixture. Okay, do the algebra, solve for h mixture, and what you get is m dot water over the m dot mixture times h of water plus m dot steam divided by m dot mixture times the h of the steam. Okay. So this would be a general result that you would get no matter what the m dots were. And this is what is left out of the solution. Okay, well, if you put in the mass flow rates, you get 100 over 200 times h of water and then 100 over 200 times h of steam. So that's a half h water plus a half h steam, which looks like half times h water plus h steam. So this is the first equation, and looks like you're just averaging the enthalpies, and that is confusing, and it doesn't need to be. Okay, so from the steam tables in the reference handbook for 60 degrees, this is for atmospheric pressure. 60 degrees, H of the water is 2808 BTUs per pound mass. The H of the steam, 1335.3 BTUs per pound mass. So put those in, the two values, and then divide by 2, get 681.7 BTUs per pound mass. And now this value for the enthalpy at atmospheric pressure puts it in the saturated liquid vapor region. So there's a quality associated with this. So the standard definition, HF plus X, the quality, times HG minus HF, or HG minus HF is HFG. So again, from the steam tables for atmospheric pressure, the HF is 180.2 and the HFG is 970.1 BTUs per pound mass. And it is actually at atmospheric pressure, that's really the latent heat of vaporization to go from liquid to vapor. Substitute that into our expression for X mixture, which will be H mixture minus HF over HFG. The units will come out to be non-dimensional, which is what we are looking for. We get the X mixture of about 0.52, which is answer C. Okay. Well, I hope that helps. Again, that concludes the presentation, and we, as always, appreciate you allowing us to help you prepare for this exam.